Hello and welcome back to Physical Science Online. Today I'm going to be going over our horsepower lab. This is a lab that we will do in class, and it is a lot of fun even if you are doing it at home. This is one you can do at home with your own data. Highly encourage you to do it because it's more fun. And this video is more or less intended for those people that are absent. And still, you can do this on your own instead of using my numbers, or if you physically aren't able to, or if you're too lazy, you can use my numbers and still get full credit. So intro, basically, if you ever heard of horsepower before, it's just a little introduction on where the term horsepower comes from. Go ahead and read through that. It is kind of interesting and it's not very long. But basically, you're going to end up finding out your own horsepower today is the real goal, especially if you would go at maximum effort. Once again, no requirements on maximum effort, no requirements on using your own numbers. Just kind of a cool to think about, and I think really fun to do that, but not everybody agrees with me all the time, unfortunately. So real quick, in class, we would ask you to give your weight, your real weight, as near as you can. We'd even have a scale. If you don't want to use your weight, I always let anybody use an average human. What's that, about like 150 for guy, or 150 or 160 for guys, 120 or 130 for girls. In general, you can use a made-up number if you don't feel comfortable using your own weight. I offer that up. I'll let you know if you're using my numbers. I'll just tell you, I'm 215. I finally got down to 215 pounds. We usually think of weight in pounds. However, for our equation, we're going to need that in kilograms. So Google, really great converter. If you type in pounds to kilograms, gives it to you there. Go to one decimal place, and that's going to be 97.5 kilograms. So that's that. And then distance up the hill or stairs. We're actually going to use stairs. Since we're not able to go outside and use the hill as much. You just need the height of it. So however, if you can take even a ruler or a tape measure and measure from the bottom to the top how high it is, the stairs outside of my room, or what we use in class, are 3.9 meters. If you measure in feet, if you're at home and you can only measure in feet because most American stuff is in feet, once again, use Google. Use that conversion ratio from foot to meters. It does it for you. You don't even need to know that. And then whatever stairs or hill you use, you're just going to run up it and time how long it takes. Now, I'll let you know, this lab is not perfect by any means. There's friction. Running at the angle isn't a perfect equation for conserving energy and efficiency and stuff like that. But it's close enough, and it gets us thinking about how to do this stuff. So first, run through the calculations, try and fit this in one video. Energy needed to get up the hill. We measure energy to get up the top of the hill. It's the kinetic energy that you need to get up there. So it's also your potential energy at the top, that conversion of energy. So I have a mass, I have a height, and I know what gravity is. So potential energy equals mgh, which means that my potential energy, or energy to get up the hill, is going to be 97.5 kilograms times 9.8 meters per second squared times 3.9 meters. Grab my handy dandy calculator here, and I get 3.9. I'm going to predict that this video is actually going to be 2 videos long. Times 9.8 times 97.5 equals 3,726.5 joules of energy. So to take me, that's why you have to use your own weight if you're actually going to do this for real. Be part of the who has the highest horsepower calculations in class. You have to use your own weight and your own times. If you're just doing it for credit, you can use mine, or you can use your made-up numbers. But either way, you need some sort of energy, the energy it takes to get up that hill. The Screencastify is warning me I'm getting to the end of my 5 minutes. So actually, this is where I'll stop this video, and we'll finish up in the second video. I do promise this time that it'll only be 2. I'm sometimes off on that, but this time around it will only be 2.